Right, this is the video for lesson 3 of the Blended Algebra 2 course, unit 5 on transformations of quadratics. Today we're going to talk about reflecting quadratic functions over the x-axis and the y-axis. So this will be a no calculator topic. However, we are going to use the calculator to start in the notes just so that we can see what's happening. So it says that we want to graph we have f of x on the graph. Right, that's what's already graphed for you. Now they want us to graph negative x squared on our calculator. We're going to use Desmos here. Right, so let me pull up Desmos. Alright, so we're going to type in y equals, and I'm going to put in parentheses just like it has, but if you don't put parentheses, that's okay. Alright, so it looks like we have our parabola, and it is upside down. So if you need the table here to plot those points in order to graph it, go ahead and use that. But it's actually going to be the same points, just upside down here. So take a minute, use your table on Desmos, and plot this graph. So that is the graph of negative x squared. So what seems to be the transformation? Well, it looks like this graph is upside down, and it was reflected over the x-axis. Okay, now the next one says graph y equals negative x in parentheses squared into Desmos. So let's type this one in. Y equals parentheses negative x squared. That's interesting. Let's plot that one. 0, 0, 1, 1, 2, 4. It looks like when I plot that, I actually get the same parabola that I started with. So it actually doesn't look any different. It's hard to see here, but that actually turns out to be the reflection of the original over the y-axis. Now the y-axis, remember, is this one that goes right down the middle here. So it was flipped over itself, and so it looks like it's in the same spot. All right, now let's take another look at a different graph here. We'll talk about square roots in a different unit, but at least this helps us visualize things here. So we have the graph of square root of x, that's the parent function. Let's graph negative square root of x on Desmos. Oops, that's not what I want. Right, so here I'm going to graph negative the square root of x. And when I look at the table here, 0, 1, 2, I put in, I don't know, maybe 4, negative 2, that looks like it'll make a nice graph here. So we had 0, 0, 1, negative 1, I actually went down to 4, 2, and then if I put in here 9, give me 9, negative 3. So this graph is negative square root of x. And similar to the purple graph up here, it looks like that graph was just reflected over the x-axis again. And it was just flipped upside down over the x-axis. Now this one's where we're really going to see a difference. Let's graph square root of negative x here. So just square root negative x. This is the one where we're going to see a difference. So I'm going to graph, let me clear out the table here, and I'll tell you what points are going to be best for us. We're going to do negative 9, negative 4, negative 1, and 0. Those points are going to be the good ones to graph. All right, so let's put those on our grid as well. When I look at those, it's easier to see this time that graph was reflected over the y-axis. So we have two different reflections that can take place. It seems like there's a negative in both of them. So all we're going to need to remember is where does the negative go, And what reflection will that be? So it looks like if the negative is out in front of the function, we're going to reflect over the x-axis. If the negative is inside the parentheses, that's going to reflect over the y-axis. Now let's look at our transformations chart here. Okay, so this is our next column down, box down here. So again, if I have a negative in front, I've got the highlighter. If I'm in front, so like a negative, then x squared, that's a reflection over the x-axis. Now the difference here on the next one is that the negative is inside the parentheses. It has to be inside the parentheses in order to be a reflection over the y-axis. Okay. So we'll leave our chart there, and let's look a little bit at the back here at a couple of examples. So we'll flip over. So we're going to state the vertex, list all the transformations, and then sketch a new picture based on the parent function here. Okay? So we have negative x plus 3 squared minus 1. Now remember, to find the vertex, you take the opposite of the number in the parentheses, which will be negative 3, and then the same as what's on the outside, negative 1. Now when I do transformations, we list them from left to right. Okay, so on the left here, I have a negative in front. And we said a negative in front is a reflection over the x-axis. So this graph is going to reflect over the x-axis. The plus in the parentheses mean I went left 3, and minus 1 means down 1. So here's what we're going to do. You're going to take each of the points on this parabola and complete those transformations. Now if I start at 0, 0, if I reflect it over the x-axis, it does not move. So then I can move it to the left 3 and down 1, and that will be its new location. The next point here, 1, 1. If I reflect it, I go down here, left 3, down 1. Okay, so you just have to go nice and careful. If you need help with this, ask your teacher. I reflect, left 3, down 1. So my first 3 points are there. This next one, 2, 4, reflects down to 2, negative 4, left 3, down 1. Okay, left 3, down 1. It should be symmetric. Now the last one, 3, 9 goes to 3, negative 9, left 3, down 1. So you should get a parabola that looks something like this. If you're having trouble figuring out what to do, pause the video, come over and ask your teacher. Right? Letter B. Negative x squared plus 4. Well, there's nothing in the parentheses after the x. So that actually has a vertex at 0, positive 4. Now that negative in the parentheses is a reflection over the y-axis, and the plus 4 means you went up 4. Now when I reflect a parabola like this, that's in the parent function form, over the y-axis, it actually doesn't move. So it's going to stay in the same spot. We saw that on the front of our notes here. When I reflect the parent function over itself, that pink graph stayed put. So here, all we have to do is now move every point up 4. 4. And there. So this pink parabola is the graph. It was reflected over the y and moved up 4. All right, last one. Negative x squared plus 6. Well, there's nothing in the parentheses with x here. So again, the vertex is at 0. The plus 6 means it's staying the same. The negative is in front of the parentheses this time. So this graph reflected over the x-axis, and it went up 6 units. Okay, so we start with the reflection. 0, 0 stays put when I reflect it, but I can move it up 6. When I reflect 1, 1, it goes down here, up 1, 2, 3, 4, 5, 6. Same thing on the other side, it's symmetric. All right, so go down to 2, -4 reflected. 1, 2, 3, 4, 5, 6. And then I'll do the same over here. And then 3, -9, I go up 1, 2, 3, 4, 5, 6. Okay. So as long as you're careful, you should be okay with graphing the parabola. All right, last one here. We are given a parabola. It's the same on either grid. It says the graph of this function is shown. Right? First thing we want to do is look at this graph and find the vertex. Here's the vertex. It looks like it's at -2, 6. And we're going to write the vertex form of this parabola because we're going to work with it here. So the vertex form of this parabola is y equals. Now my parabola is upside down, which means at some point it was reflected over the x-axis. So when it's upside down, opening down, we put a negative in front. In the parentheses, I'm going to have an x. Now I have a -2, which means I have to put a +2 here, squared. And then a +6 for the y means I have to put +6 on the end. Now what we're going to do with these two graphs is we're going to first reflect the left graph over the x-axis. So you're going to take every point on this graph and just reflect it over this axis. All right, so let's take each point. So I'm going to move this point first. And if it's 3 below the axis, it's going to move the 3 above the axis. And then this next point's 2 above, so it goes 2 below. 1, 2, 3, 4. This one's 5 above, so we go 5 below. Here. It should end up, oops, that's not right. Should end up symmetric here with a parabola that looks like this. All right, now let's write this vertex form of this graph. So the new vertex, when I reflect it, is right here. That is at 2, -6. It's opening up this time. So when I write the vertex form, I don't need a negative. My vertex is at, oh, I'm sorry, it's at -2, -6. So my parentheses will be x +2 squared -6. All right, last one here. I'm going to reflect this graph over the y-axis. So we're going to flip everything over that green line. So if I'm starting at the vertex 2 to the left, I want it to be 2 to the right. Here I'm 1 to the left, 1 to the right. Okay. This point's on the axis, stays the same. And then 4 over here. Over. There we go. All right, so if you need to slow it down, pause the video or ask your teacher to help you. But it's hard without me here pointing at things. You have to go off the video. The new vertex here is at +2, 6. So when I write my vertex form, the graph is upside down again. So I'm going to have a minus sign for upside down. And in the parentheses, an x. I'm going to go the opposite of +2, which is -2 squared, and then +6. All right, there is some practice. This is no calculator allowed. Go ahead and try the practice. If you need help, ask your teacher or check the key posted on campus.